So today we are going to discuss the chapter force and pressure. And don't ask me why I'm wearing this hat. This is because of a personal issue. Okay, so let's start. As I've already explained in the live class that day, so you have already know that there are five effects of forces, then two types of forces, contact and non-contact forces, then moment of a force. So we are going to discuss those topics in this video. Okay, let's start. See, what is force? What happens when a force is applied to an object? While pushing, pulling, lifting, or hitting anything, we are actually changing the motion of an object. This change in motion requires force. So we can say that a push or a pull on an object resulting in its motion is called a force. See, what happens when force interact? If you choose a heavy box and try to push it, the box will not move. Now, if you ask a friend to help in pushing it in the same direction, it moves. This experiment proves that the forces are acting in the same direction adapt. Now, effects of force. Consider a thin rubber balloon and blow air into it. The shape changes. Then tie it open end with a thread. Now press the air-filled balloon again. The shape changes. This is due to effect of force. Now when you play football, the football is kept in the center of the field. When you kick it, it moves towards the given direction. Similarly, in the kitchen, your mother makes the balls from dough and rolls them into chapatis. In this case, she is applying force to make them flat. Now, see, one can change the direction of the object by applying suitable force on it. For example, in cricket, the speed of the ball hit by a batsman reduces to zero when the fielder catches it. Also, if you kick a moving football, the speed of the football increases, right? Now, kinds of force. There are two major types of forces. One is contact force, then another one is non-contact forces. In contact force, there are muscular force, force of friction, etc. Then in non-contact force, examples of non-contact forces are magnetic force, gravitational force, and electrostatic force. Can you push or lift a book lying on the table without touching it? Or can you lift a bucket of water without holding it? In both the cases, the answer is no. Generally, to apply force on an object, our body needs to be in contact with the object. So we can say that contact forces are the forces which act on bodies when they are in actual contact. Basically, these are two types, muscular force and force of friction. Muscular force. When we push an object such as a box or lift a bucket of water, then the force is caused by the action of muscles in our body. This force is known as muscular force. For example, cutting the vegetables or fruits with the help of knife, hammering of nail with the help of hammer, pulling a cart by horse. Then comes the force of friction. Do you know why a heavy box on pushing does not move? Why a rolling ball stops after some time? When an object moves in contact with another object, a force known as friction comes into play. This shows that force of friction always opposes the motion of one body over another body in contact. Then comes the types of non-contact forces. Non-contact force, there are three types of non-contact forces: gravitational force, magnetic force, and electrostatic force. Do you know why the leaves of fruits fall to the ground when they detach from the plant? This is because of gravitational force. The force due to Earth's attraction is called the gravitational force. This is an example of non-contact force. Then comes the magnetic force. Now the force between two magnetic poles placed at a suitable distance is called a magnetic force, in which like poles repel while the unlike poles attract each other. A magnet can exert a force on another magnet without being in contact with it. So the force exerted by a magnet is also an example of non-contact force. Now, do you know when we rub a tube through dry cloth and bring it near the thread is attracted towards the thread. This is because on running the tube through the dry cloth, an electrical charge is generated on the tube. This is called the electrostatic charge. This is also an example of non-contact forces. Think of a spanner loosening a fixed nut, or a child on a seesaw, or a door opening around a fixed hinge. All of these things are connected by something called moments. A moment is the turning force around a fixed pivot. The pivot is a nut or the middle of the seesaw or the hinge. We can have one moment acting which results in a turning force, or if something is balanced or in equilibrium, the moments are equal and opposite. To be balanced, the lighter child needs to sit further away from the pivot and the heavier child needs to be closer. This is because the size of momentum is determined by the force and the distance. So the moments of the lighter person is 500 newtons multiplied by 2 meters. That means 1000 newtons. And the heavier person is 1000 newtons times 1 meter also gives 1000 newton meter. They are perfectly balanced on their seesaw. Did you notice the moments are measured in Newton meters? Newton meter because force is measured in newtons and distance in meters. Note that the distance must be perpendicular distance from the pivot to force. Here's another example. Can you work out what moments the omen is applying to tighten the wheel nut? Pause the video and work it out. Did you get the 3 Newton meter? Very careful to change the 30 centimeter into meters. We can also place this formula into formula triangle. Force equals momentum divided by distance. Distance equals moments divided by force, and moments, as we already know, is force times distance. Here are two more questions for you to try. Pause the video, work them out. Did you get the both questions right? For this seesaw, we do actually say clockwise movements and anti-clockwise movements, and for something to be balanced, the clockwise and anti-clockwise movements must be equal. So there we have moments. They are measured in Newton meters. Effects of force. The first effect is a force can make a stationary object move. For example, when you kick a stationary ball, it moves. Then, a force can stop a moving object. For example, when you catch a ball, you stop the ball from moving. Third one is a force can change the speed of moving object. For example, when you push a swing, it moves faster. Fourth one is a force can change the direction of motion of a moving object. For example, when you hit a tennis ball with a racket, its direction of motion changes. Then the last one is a force can change the shape of an object. For example, when you squeeze a rubber ball, its shape changes. Then we have the units of forces. The SI unit of force is the Newton, and Newton is the force needed to increase the speed of an object of mass 1 kg by 1 meter per second in 1 second. The unit is named after Isaac Newton, who formulated the laws of motion and gravity. Force is also expressed in kilogram force, which is written as kgf. A kilogram force is the force that pulls an object of mass 1 kg towards the earth. A kilogram force is equal to approximately 10 Newton. For more accurate calculations, a value of 9.8 Newton is used. Thus, on Earth, 1 Newton is approximately the downward gravitational force exerted on an object of mass 100 gram. Then we have turning effect of force. So I have already discussed the moment of a force, then turning effect of a force in the video. Now see the definitions, some of the definitions in this topic. First one is movement of the whole object from one point to another is called translatory motion. Then we have when a force is applied to a suitable point of an object which is fixed to a surface at a point, it may rotate around a fixed point. This is called the turning effect of force. Then the turning effect of force around a fixed point is called the moment of the force or moment, and also torque. A force makes an object rotate only if there is a point or axis on the object that does not move. This is called a pivot. The object rotates around a pivot. Then, if the force rotates or turns the object in a clockwise direction, the movement is called a clockwise movement. And if the force rotates or turns the object in an anti-clockwise direction, the movement is called anti-clockwise movement. Next, we have the factors affecting the moment of a force. First one is the magnitude of the force applied. The greater the magnitude of the force applied, the greater is the moment of force. Then the perpendicular distance between the pivot and the point where the force is applied. The larger the distance between the pivot and the point where the force is applied, the larger is the turning effect. So in this topic, we have two factors that is affecting the moment of force. First one is the magnitude of the force applied, then the perpendicular distance between the pivot and the point where the force is applied. Next, we have unit of moment of a force. See, the perpendicular distance from the pivot to the point where the force is applied is called a moment arm. The moment of a force is the product of magnitude of the force applied and the moment arm. So, moment of force is equal to force into moment arm. Now, we can write as capital M is equal to capital F multiplied by small d. Since the SI units of force is the Newton and distance is the expressed in meters, the unit of the moment of a force is the Newton meter, which is written as capital N and small m. So the part of force is completed. Now, see, we have learned that effects of forces, types of forces, that is non-contact and contact forces. So under contact forces, we have learned the muscular force, friction, force of friction. Then in non-contact force, we have learned gravitational force, electrostatic force, and magnetic force. Then we have learned the turning effect of the force, factors affecting the movement. So we have completed the force part. So in the next video, I'll try to give you the question answers. Okay. So this much is for today. Thank you. See you soon.